மேம் ஓகே மேம் கரெக்டா இருக்கு. கேக்குதுங்களா?
ஓகேவா விக்னேஷ்?
ஐம் ஆடிபிள்.
ஆடிபிள்
ஓகே மேம். ஆடிபிள் மேம். இதே Zoom ஐடி, இதே Zoom லிங்க், இதே நம்ம யூஸ் பண்ணிக்கலாம். ஓகேங்களா? நோ சேஞ்ச்ல.
ஓகே
பக்கா கரெக்டா இருக்கு. ஓகே மேம். ஓகே மேம் ஃபைன். அதாவது நீங்க செக்ஷன் ஆரம்பிச்சு ரெக்கார்டிங் பண்ணி ரெக்கார்டிங் பண்ணி லிங்க் எடுத்துட்டு நான் டவுன்லோட் பண்ணிக்கிறேன்.
சரி.
நீங்க இதுல பண்ணிக்கலாம். ஓகேங்களா? थैंक यू மேம். थैंक यू so much.
யா ஓகே.
ஓகே மேம். இது பார்ட்டிசிபென்ட்ஸ்க்கு அனுப்பிச்சிடுறேன் மேம் எல்லாருக்கும்.
அனுப்பிடுங்க. நீங்க தம்ப்நெயில் அனுப்பிச்சிட்டீங்கல்ல?
தம்ப்நெயில்ல வந்து சாரோட இமெயில் காமிச்சிருக்கேன். சாரோட இமெயில் காமிச்சிருக்கேன். பிரபாகரன் சாரோட இமெயில் காமிச்சிருக்கேன். கொஞ்சம் அது மட்டும் செட் பண்ணீங்கன்னா will be great.
சரி நான் பண்ணிடுறேன்.
ஓகே மேம். थैंक you so much.
ஓகே. யா. Vignesh.
Yes ma'am.
விக்னேஷ் நான் அலோ பண்ணமா பார்ட்டிசிபென்ட்ஸ் உள்ள உங்களுக்கு கோஹோஸ்ட் கொடுத்துருக்கு.
ஓகே மேம். நானே அலோ பண்ணிட்டுங்களா?
நான் இங்க டிசேபிள் பண்ணிடுறேன், நீங்க அலோ பண்ணலாம்.
ஓகே மேம், தேங்க் யூ. Yes ma'am. Yes ma'am.
விக்னேஷ் அலோ பண்ணமா பார்ட்டிசிபென்ட்ஸ் உள்ள உங்களுக்கு கோஹோஸ்ட் கொடுத்துருக்கு.
ma'am, I'm allowing ma'am. Okay ma'am, நானே allow பண்ணி.
Yes, allow பண்ணலாமா விக்னேஷ்?
இல்ல சார், அலோ பண்ணியாச்சு ஆல்ரெடி. அது
ஓகே மேம்.
யூடியூப்ல நம்ம
we allow ma'am.
ஜீவா.
சிவகுமார் சார் வந்துட்டாருங்களா மேடம்?
ஒரு 2 மினிட்ஸ்ல வந்துருவார் சார்.
ஓகே.
Dear participants, we'll start the section probably in 5 to 10 minutes. Thank you for participating in the section. We'll shortly intimate you
So good afternoon, friends. Good afternoon, all of you.
good afternoon, sir. Can we start, sir?
Yeah, I'm ready, sir. I just joined.
Okay, fine. Okay, welcome you all to the webinar. I request Dr. Ramakrishnan sir to address the gathering with welcome speech.
Audio.
Very good afternoon to you all. Good afternoon, sir. Sivakumar sir.
Yes, sir. Very good afternoon.
Welcome. Welcome, sir.
Welcome. Thank you.
First, I would like to say a few words about this today's program. The program, Statistics for Sports, application of statistics for sports. That is the today talk going to be delivered by Professor Dr. Gopal Sivakumar. So the importance, I would like to say a few words. More elaborated discussion will be held by Dr. Sivakumar sir. Before that, I would like to say the significance and the major outcome of this program for this audience. So as we all know that statistics plays a very significant role in all research, including sports. So though other computer-based modeling and analysis optimization techniques are popular in the present scenario, but till statistical analysis plays a very significant role because of its less complex involved in the problem solving and data analysis and all. Keeping this in view, most of the problems persist. Research problem persists in the various kinds of sports applications. This topic has chosen for the benefit of the researchers, those who are involved in various kinds of sports applications. So keeping this in view, the Department of Sports Technology of Tamil Nadu Physical Education Sports University is going to organize this program. That is the motto and the significance of organizing this today's program by the expert Dr. Gopal Subramaniam. Then there are we all know that nowadays that computer-based modeling and optimization technique such as artificial neural network, that genetic algorithm and fuzzy logic model and colony algorithm, particle swarm technique, and so many modeling techniques are available. Similarly, for that other dynamic analysis, CFD, computational fluid dynamics, and the finite element analysis, these are also very popular. But though those computer modeling and optimization techniques are persist, but the statistics as having its own influence because of its less complexity involved, and it is very simple to use. But the those who have not much knowledge on the artificial intelligence and the computer-based thing, also easy to use this technique. That's why we are focusing on this topic particular. Once who are well versed on this basic statistical analysis, they can perform that.
I think sir has some connectivity issue.
Sir, Ramesh, sir?
Yeah, I think sir has some connectivity issue. His video got stuck.
Sir, just a second, sir.
Vignesh.
Yes, sir. Sorry.
Sir can start actually because I think there is some problem there.
Okay. Okay. Sorry for the inconvenience, sir. Sir, I request you to start the section, sir.
Okay. Oh, sure. Just a minute. So once again, very good afternoon to all of you. A warm welcome to today's program, Statistics for Sports Analytics, right? So first of all, I would like to thank Tamil Nadu Physical Education and Sports University for giving this wonderful opportunity to conduct this 2 hours webinar, right? For all the research students and people who are connected in the field of sports education, the professors and researchers. So I wholeheartedly welcome all of you for this webinar, and thanks to the officials at the university, the Vice Chancellor, Dr. M. Stender, and Registrar, Dr. Gopinath, Head of the Department, Dr. Ramakrishnan, and the Professor Coordinator, Dr. Nallavan, and also thanks to the program coordinators, Mr. Vignesh and Punithan, for creating a wonderful platform, and that reflects in the the number of people in the meeting. So thanks to all of you for this nice opportunity, and let me share the screen and also take you through the program. And I'm also a special invite to Mr. Vinod Shankar, the Head of Operations with the Vision Excellence. Welcome, sir. Yeah.
Thank you.
Yes. So I'm just sharing the screen. Quick confirmation, is my screen properly visible and I am properly audible to all of you? Need a confirmation?
Yes, sir.
Yes, sir.
Okay, thank you.
Yes, sir.
Statistics for sports analytics. So I'm going to stick to the fundamentals, right? Though there are advanced things, artificial intelligence and other things, always the fundamentals help. So I'll take you through the basics of the statistics and how we can use statistics, for research in the field of sports. So all of you can feel free with me. Feel free to interact, and often I will stop so that you all can ask me your question, and stipul time will be allotted. I have designed the program in 3 phases. So probably after the completion of every phase, I'll stop for 5 minutes to take your questions, right? And all of you please switch off or keep your other electronic gadgets in silent mode so that you are fully devoted to me, devoted to the webinar, and you are focused here, right? And whoever possible, you can stay on video and then, but see to that, you are muted, your background is silent and all those things. And you can ask me questions through hand raise options, and then the host and co-host here will allow you to speak to me. Right. By the way, this is Dr. Gopal Sivakumar. I hold a doctorate degree in mechanical engineering. And I have the balanced wealth of experience in teaching, research, as well as training and consulting. So some of my expertise areas include statistical process control, measurement system analysis, hypothesis testing, correlation, regression, and of course, we call it Lean and Six Sigma, right? Tools and techniques. So I have vast experience in those areas. And almost all the tools can be used in research also very well. And that's why I'm connected with this program and I'm addressing all of you now. Right. So this is a brief about me. Okay. So I was informed about the background of the participants. So I understand there are a lot of professors, a lot of researchers who are connected to the sports, research in sports. So I will stick to align to your expectations. Right. So these are the expected outcomes when you actually participate in the program. I'll help all of you understand as well as apply descriptive and inferential statistics in your research works, right? And how to understand the worthiness of the data, whether the data collected in my research is really worthy for analysis. Can I move on to understand the problem deeper, to understand what kind of improvements can be suggested? Analysis is important, but when you are actually doing the analysis, you are using the data. Is that data really worthy for that purpose? Or if the data is really not credible, not worthy for analysis, then you should also be boldly throw away the data and then try to correct the data collection procedure, and thereby you can actually make the data worthy for the analysis, and thereby your research findings can make sense to the society, right? So we'll talk about that one. That will be the second part of the talk. And then the third part, we will discuss a case study. How statistics is used in sports to bring about some improvement or to get a problem solved. And I'll be taking you through analysis in cricket, where a team is able to, or a research team is able to improve the batting performance of a particular batsman, right? So probably we'll keep half an hour for each and everything. And then the last half an hour we can spend by having some good interaction. Right. So what is this descriptive statistics and the inferential statistics? First of all, what is statistics? Right. And see here, imagine you are standing in a signal or you are doing a survey, right, of the kind of vehicles that are crossing a particular signal point. You have been doing this study over a period, maybe for about 3 months or 6 months, and you collect a lot of information. How many public vehicles are moving and how many passenger vehicles are going on, and how many of them are two-wheelers, how many are three-wheelers. So much of information you collect. You did a survey, right? You collected data, right? And after completing your study, let's say for a period of 3 months, you understood that on an average, 3,000 vehicles crossed that particular signal during a peak hour, right? And out of that 3,000 vehicles, see, this is only average. Please note, average is a statistical parameter. We use it here to make some conclusion. Always the central value are required to make the conclusion, right? Always the measure of the variation needs to be understood, right? Needs to be understood to rely on your conclusion, right? And we will talk about in depth in the first module. And out of the 300 vehicles which are found to be crossing the signal in that particular period, particularly peak hours, approximately 1,350 of them are passenger cars and 600 are public vehicles, and around another 1,050 are 2 and 3 wheelers. So you collected data. You see here, date wise, you collected the data. Then you summarized it. Then you visualized it, you presented it, and see here, and majority of them are the passenger cars. And the next in line is the public vehicles. And the third option is 2 and 3 wheeler. So you can classify according to a requirement. So now here I just classified into 3. And what is the interpretation here or the finding here? Overall, 3,000 vehicles cross that particular area during the peak hours, maybe in the morning or so, right? And out of them, 45% of them are the passenger cars, 20% of them are public vehicle, and 35% of them are 2 and 3 wheeler. So some analysis is done, right? And interpretation is arrived. So this is what is exactly statistics. You collect data to understand what is happening. You collect data to understand what is happening. And you present the same data so that the reader can understand in a better manner. So why do you collect the data? Why do you want somebody to read your data and understand? Because ultimately they wanted to take more effective decision. So statistics helps in making effective decisions, right? So what is statistics? So statistics is the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decision. Very simple, right? So statistics helps in making more effective decision. What is effective decision? Whatever decision you are taking, that will happen in real time. If your statistical findings are something and realities are going to be completely different, your research is not effective. So we need effectiveness, in our work, right? So that's what statistics helps in, achieving. So a collection of numerical information is called statistics. This is what we did. 3,000 vehicles cross the signal during the peak hour. 45% of them are passenger cars, and 20% of them are another category, and 33% of them are some other category. Similarly, you can bring about a lot of examples for statistics, right? In our university, 50-60% of them are actually male students, and 70% of the students are postgraduates, and 20% of them are graduates, and 10% of them are researchers. So these are all statistics. A typical automobile in the US is found to travel a distance of 11,099 miles every single year. How do they know? They have some information, they have data. And this is statistics. And a typical bus, it covers 9,300 odd miles every single year. A typical truck covers 13,942 miles every single year. This is how the automobiles and the vehicles are used in US. How do you know? The data is collected, and then by presenting the data and analyzing the data, you have come with the conclusion. Now this is how statistics helps. So you can judge on what has happened. You can also judge on what is happening. You can also judge on what is going to happen in the future. So statistics can help you to understand the past, the present, and also the future. So your understanding about the past, your understanding about the present, if they are good, probably your understanding about the future, the prediction may also go good, right? At the same time, it depends on the quality of data. If the data is free from errors, then you can better understand. We are going to talk about that, right? So the quality of data finally decides the quality of your research conclusions. Similarly, in Canada, the numbers are going like this, running like this: 10,371 automobiles, 19,823 buses, and 7,001 miles for as far as the trucks are concerned. This is how vehicles are used in Canada compared to the America. And in a company, the mean waiting time to receive a technical support is 17 minutes. I purchase an electronic gadget or something, and then I have an issue with it. So I just send a request, raise a ticket, and when do I get the support? There are thousands of people who purchased, like me, and thousands of problems are happening, and all of them are raising a ticket. And every customer will be waiting for a certain period of time to receive the support. The numbers may be different for different customer, isn't it? It's quite possible. However, how do I understand how my company is really supporting my customers when they actually raise a ticket? When I have the proper data, I can again analyze the data and understand. So what is the understanding here? On an average, it takes 17 minutes for the company to resolve or to support a customer whenever he raises a ticket, right? So see here, the average or the mean is nothing but the central tendency in your data. It is the central tendency which helps you to take decision. It is the variation in the data that makes that contributes to the accuracy of the decision. We will talk about that. So let's say, what is statistics, basic statistics, or the purpose of statistics? It helps in three ways. Ultimately, any research, ultimately will fall under any one of the three categories. First use of the statistics. It helps you to summarize the data with the central value. In statistics, we call it central tendency. It can be mean, or it can be median, or it can be mode. Most of the time we use mean, particularly when your data is continuous, when it is measured in a ratio scale. We prefer mean as the central tendency. But there are certain occasions we use mode as the central tendency. In certain occasions, we use median as a central tendency. For example, generally for the salary, median is used as the central tendency. And for kind of nominal data, mode is used as the central tendency. But most of the time, for any measurable data like temperature, pressure, the batting the run score, right, and all these things, we use the continuous data. Under such situation, mean helps us to understand the central tendency. And number two, statistics helps us to assess the degree of variation. More the degree of more the variation, the more is the uncertainty that exists about your decision you arrived using the central tendency. You arrive on the decision using the central tendency. Though you collected data, though you calculated the central tendency, though you concluded something, is that the conclusion is going to be the exact reality, or is it going to be different? It can be exact reality. It can be exactly the opposite. So statistics is not like your mathematics. It doesn't work as an equality. Statistics is all about inequality. Any conclusion, any findings will always comes with certain amount of certainty, certain amount of uncertainty. The amount of uncertainty can be understood using the amount of variation or the intensity of variation. If you minimize the amount of uncertainty, what will happen? The amount of certainty will increase. If the amount of certainty increase, then your confidence on arriving on a conclusion using the central tendency will actually improve. This is how the statistics, though these are very simple concept, but goes in helps you in a fantastic manner when you are actually doing research and then making some conclusions out of it. The same statistics, nothing but set of data, can be used to explore possible difference that may exist between two groups. Team India is playing against Team Pakistan, right? And Team A is playing against Team B. Or in a tournament, there are 10 teams are playing, and only one team can be given, the cup, the trophy. Why are you giving cup to that one single team? Because their performance is found to be significantly better than all the other teams who participated in the tournament or the series. So the word significance is important. You are not, issuing the trophy, just like that. You are estimating whether their performance, whether their capability of playing the game is significantly better than the other people or not, right? So you can use statistics to explore possible difference between two or more groups. See here, I have certain data here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 data, some numbers. You can imagine whatever it is. It can be the run scored by a batsman, or it can be the number of goals, made by a team in the last series, a hockey team or football team, something like that, right? Or if you are in a manufacturing segment or something, you can consider these numbers as the number of defects, whatever it is, right? And see here, I just used all these data in a statistical analysis software and then asked for a descriptive statistics. What is descriptive? You are just narrating how beautiful the person is. You are narrating, you are writing about one full page. Whenever you see a cine actor or a cine actress, you narrate them for 200 pages. Same way, can you narrate what is happening in the process from where you collected the data? That narration is nothing but descriptive statistics. Once you make these kind of values, the data will start speaking to you. The data will start speaking to you. The data will help you to understand what you have actually seen. Will help you to understand the characteristics of the population from where you actually collected the data, right? See here, n equal to 12. That means there are 12 data are collected. The sample size is 12. Mean 3.633, nothing but the average. You add all the value, divide by 12. Standard error of the mean, when you calculate, that will help you to locate the prediction interval limits, the limits of the prediction interval. The limits of the prediction interval can be located by the standard error of the mean. We are going to talk about it today. Though it's a short webinar, we are going to talk about it, and I'll make sure you all understand the importance of the prediction interval and importance of the confidence interval. Then trimmed mean. A trimming is cutting, I just cut down a small portion, so it becomes 3.5. That's it, right? Standard deviation. How far each of your data from the mean value you calculated. Look at the data. Every data is at a distance of some value from the mean. 6 is away from the mean. 10 is far away from the mean. On an average, what is the deviation? You have 12 number. Every number is at a distance from the center. But on an average, what is the distance? That is what is called the standard deviation. This standard deviation helps you to locate the limits for the confidence level on the mean calculated. Confidence level on the, so standard deviation helps in determining the confidence limits. Standard error of the mean helps in determining the prediction limit. Of course, both will depend on the central tendency. We will slowly dive deeper into that. And then variance. What is variance? The square of the standard deviation. The square of the standard deviation is variance. Sum, you add all the value, that is the sum. Minimum, what is the lowest here? Number 1 is the lowest. So what is the maximum? 10. What is the range? The difference between the maximum and minimum, which is 9. You can see these are all calculated by the software. If I am really strong in terms of statistics and the concepts, then I can use all these softwares and then make meaningful decision. When my decisions are meaningful, my research can also become meaningful. When my research is meaningful, it can help the society and help the country, isn't it? So what else is here? And Q1 means quartile 1. What is quartile 1? The point below which 25% of my data are present. You can calculate that also. There are some formulas and by which you can actually calculate, right? And it is calculated 2.25. That means if you calculate the number of the data below 2.25, you will see at least 25% of them, right? And that's the meaning. Median, the 50th percentile data. That means below this point, 50% of the data will lie. Above 50% will lie. That is called median. Q3, quartile 3. Quartile 3 means below 75%, above 25%. And maximum, minimum, the range, quintile, quartile range, Q3 minus Q1. What are we doing? We are trying to understand how our data is distributed. How our data is distributed, isn't it? That is what we are trying to understand, right? And mode, the most frequently occurred data. You can easily understand which is most frequently occurring here. 3 is repeatedly occurring. 4 times it occurred. So that is called mode. The frequency of occurrence for mode is 4. So you might think all the calculations are very simple here, but it goes, a long way, when you are actually using data in research. So what is descriptive statistics and what is inferential statistics? You conducted a study over a period. Now you are presenting the information to somebody. Now what is this study? Is it descriptive or inferential? Something has happened already, right? And this particular area is loaded with heavy traffic and a lot of vehicles are crossing the point. People are struggling. So you did a study and now you tabulated it, you visualized it, and then you worked out some statistics. And you are helping everybody understand what is actually happening. That is descriptive statistics. That is descriptive statistics. And now, since the pain experienced by the people because of the heavy traffic and other thing is are understood to be very heavy, maybe the administrator decided to come out with a flyover kind of thing in that place. If I construct this kind of a flyover, what will be the benefits? Now I am concerned about the future. When this many people are struggling, when this bridge is in place, now how many people might get benefit? Maybe next year, maybe after 3 years, maybe after 5 years. And now this data is helping me to understand what has happened in the past, and the same data is helping me to understand what is going to happen in the future. When you use the data to understand what has happened, then it is descriptive. When you use the data to understand what is going to happen, then it is inferential. When you use the data to understand the characteristics of the population, right? And that is, the data is available, the population is available. Only thing is, you just collected the data and then you understood the characteristics. Suppose you really don't have access to the population, but you still wanted to understand the characteristics of the population. And then probably you will take a small sample. You will go for a small sample of data from the population. And then using the way that the sample is behaving, you will try to judge on the characteristics of the population. That is also inferential statistics, right? So if you have access to the population, collect the data, present it, it is descriptive. You have certain limitation, you are not able to reach to the population data. So you wanted to be very optimistic, you only take a sample, but still you wanted to better understand about the population. Now it is inferential. Hope it is clear to all of you. So this is a descriptive case, I would say, right? Because this we have already discussed. This is the survey, and survey has reflected, what is happening in that particular locality. So descriptive methods, descriptive statistics are the methods of organizing, summarizing, and presenting data in an informative way. If you use the data to summarize the past population, your approach is called descriptive statistics. Another statement here. An average person spent $103 on traditional Valentine's Day in 2020. So 2020 already over. And you have some data and it is understood that an average individual, maybe a person, spends $103. And they also, and it is found that there is an increase of $0.5 from the previous year. So what is this? This is a descriptive statistics. Now, how much an individual in the same country may spend next year? That question will get answered by the inferential statistics, right? And another statement, men spend nearly twice the amount women spend on a holiday. Because on an average, a man in US spent $135 to impress the people in his life, while women could only spend $72. This is again a statistics. This is again descriptive. How are you able to make all this statement? Because data is available. The population data is available, and then you just summarized it, and then you concluded. Now moving on to the inferential. If you use the data to estimate future population is you don't have access to the population, right? You wanted to predict about the future characteristics, right? And under such situation, in the statistics used is called inferential statistics. Our main concern regarding inferential statistics is finding something about the population from a sample taken from that population. From a sample taken from that population, right? Let's say I wanted to understand about the Tamil Nadu Sports University, how the students are performing. I'll take a sample of students from the same university and study how they are performing, and then I will make a judgment on the whole lot of students studying in the same university. Then this is inferential statistics. So inferential statistics are the methods used to estimate the property of a population based on a sample. Using a sample to learn something about the population is done extensively in business, agriculture, sports, politics, government, etc., 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 etc. Everywhere. You can use it wherever it is required. You wanted to understand how the metabolism is happening in your body, then you must require statistics. Any professional can succeed only if he use his professional domain knowledge along with the statistical knowledge. Otherwise, the domain knowledge will not yield the desired result. Whatever is your domain, learning statistics and knowing how to mix up the statistical knowledge with the domain knowledge can only make you a leader. So a random sample of 1,200 graduates from a university, their starting salary was found to be $42,000. That means when I admit my child in the same university, then my child may also get such a salary. This is how people choose the university. So this is a kind of inferential statistics. But the accuracy of your finding depends on your data. I already told you. This statement 42,000 came using the central tendency. But how accurate your central tendency is, that depends on the variation in the data. That is what we are going to talk about. So let us say Virat Kohli's batting average is 59.62. I think, do I need to give an option here for any questions? Anybody would like to ask me a question before I proceed about the first thing, descriptive and inferential statistics? Okay, we'll move on. Right. So let us take Virat Kohli's batting average is 59.62. That means what is the score we can expect from him in the next match? How do you guess? Since his batting average is 59.62, he can score around 59.62. That means you will expect him to score somewhere between 50 and 70. Judgeable, isn't it? I think all of you will agree with me. When somebody is having a 1 year average of around 60, then in a match you can expect him to score anything above the average. I mean above the average or below the average. That means these numbers are nothing but your confidence interval. You are expecting that particular individual to score between 50 and 70. And how did you arrive on the 50 and 70? Using the average and using your statistical knowledge. Knowingly, consciously, unconsciously, all of us are using the statistical knowledge. If you use it consciously, then you will shine very well in your career. So this is called confidence interval. Now it is to be noted that normally any data will cluster around the mean. When the mean is 60, then the expectation is also the person will score around 60 only. He may score 58, he may score 62, but anyway, it is close to the average. So that is what is written here slightly statistically. The data will cluster around the mean. Look at the limits of your confidence interval. One is 50, which is below the average. Another one is 70, which is above the average. So you can understand your data will get distributed equally about the mean. These things, these are certain characteristics of your data. If your data follows all these things, you can understand your data is a normal data. This is what we call it a normal distribution in statistics. Most of your data will cluster around the center, and approximately half of the data will be on the right side of the center. Approximately half of the data will be on the left side of the center. And so you call the distribution as normal distribution. Whenever you see these things happening, it is quite obvious. It is quite normal. Now the confidence interval depends on the standard deviation of the data. Within that 1 year, Kohli played 100 matches. So 100 scores are there. With 100 scores only, you calculated the average. With the same 100 score, you can also calculate the standard deviation. You can also locate the confidence interval. There is a simple formula. In fact, there is a concept based on normal distribution, right? And if you learn that, then you yourself will be able to locate the confidence interval. Now, I also want to know, Virat Kohli is going to play, let's say, another series next 3 months. Now, I want to judge on his batting average in the next 3 month series. You need to understand the difference. Earlier, I was about to judge his score in the next match so that I can bet accordingly and then win the thing. But now my judgment is going to be on the average of the several performance that are going to happen in the next 3 months. It's not individual value now. It is, I am going to judge on the average again. Earlier, I was judging on the individual value. I called it as confidence interval. Now it is going to be, a judging on the average. And now can you be little more, closer to reality? Judging becomes easier now. Predicting one observation is, too tough. Lot of uncertainty involved. But when you are going to judge, if a person maintains an average of, let's say, 60% in the 4th semester, it is most likely that he can maintain the same 60% in the 5th semester also. Possible. But judging on the score on a particular subject can vary by a big margin from the average. So you need to understand what you are actually trying to judge, what you are actually trying to predict. Now I'm trying to predict the average of the future performance. Now the interval will be called a prediction interval. You will be happy to see that your prediction interval is narrower than the confidence interval. Your prediction interval will be narrower than the confidence interval. Look here. If one batsman has a batting average of 60 this year, then next year batting average will be much closer to 60. I don't have a wider limits here. How it become narrower? Because now my focus is on the average of the future performance, not an individual value. And for the average of the future performance, the interval is called a prediction interval. You can even locate the prediction interval. How can you locate the prediction interval? You need to use the standard error of the mean. So what is standard error of the mean? Nothing but standard deviations of the means. Standard deviation of the data is different. Standard deviation of the mean is different. Probably I will take you through deeper into all these things in the main training program, which we are planning to conduct. Probably in the next month, you will be informed about that. Hope all of you are good with me so far. Any questions, please raise your hand. We can answer you. All right. Now, accuracy of the research, accuracy of the findings, accuracy of the conclusions, the inference, the quality of inference. The quality of inference depends mainly on the variation in the data, because you draw the inference using the central tendency. You draw the inference using the central tendency, but the quality of inference, the accuracy of inference will now depend on the variation in the data. So I write like this: accuracy of inference is function of the variation. So what is variation? The distance of each point from the central tendency. This is called deviation. I take the average of the deviation, that is standard deviation. Standard deviation is a measure of a variation. Either you use standard deviation or use square of the standard deviation, which is variance, or you use the range, you are trying to estimate the variation in the data. Now, confidence interval is a function of standard deviation of the data used to calculate the mean. Your prediction interval is a function of standard error of the mean. What is standard error of the mean? Standard deviation of the means of the data. So lower the error, narrower will be the intervals. So make sure the error in your data is minimum. Error, nothing but the variation in the data, right? And the variation can be due to the the real performance. Sometimes the error can also happen artificially. It could be because of the measurement system you are using. You may bring about certain error. Sometimes you may not know how to collect the data. Then that will also bring about the error. Then that will lead to wrong conclusion, wrong inferences, right? So that's why we should keep an eye on the variation, particularly keep an eye on the error. So narrower the confidence and the prediction interval, conclusions will be more accurate and more and more meaningful. If your intervals are narrower, then the certainty is higher, uncertainties are lower. When your confidence interval or the prediction intervals are very wider, it simply means uncertainties are very high. When uncertainties are very high, and people may not appreciate your findings. Whatever you find, at least they must be able to see in real time. So we are trying to measure the amount of certainty and the amount of uncertainty that is associated in our research conclusions. This is what we sometimes call it as the confidence level and the power of the research study or the power of the test. Am I going good? Is that all of you are able to follow me? Give me some signal, maybe some kind of reactions you can show, or you can put in the chat box. Yes, Raji, I can see your thumbs up. How about others? All of you are able to follow me properly?
Very good.
Fantastic, fantastic. Right. I wanted to keep things as simple as possible so that all of you will really be able to derive some knowledge out of the session. Very good. Now, moving forward. And now, statistical significance. We talked, please note, in one slide, I talked about central tendency, which is one use of statistics. Another thing is variation, which is another use of statistics that talks about the error, that talks about the uncertainty. Then the third thing is significance. That is what I'm going to address now. Statistical significance. Is there a statistically significant difference that exists between you and me? You also write the exam, I also write the exam. I got 60 mark, you got 65 mark. Does it mean your knowledge level is better than me? Your mark is 65, my mark is 60. Similarly, Team India scored, the Kohli's average is something. Rohit Sharma's average is something. Does it mean Kohli is better than Rohit? Statistical significance. There is a difference. 60 and 65, there is a difference. You should not believe all differences. You should believe the difference only it is statistically significant. So understanding what is statistical significance is very important in making effective decisions. Otherwise, you might think that the Kohli is better than Rohit, and then the performance may be completely opposite. So when you are a coach, when you are a researcher, you have to take your decisions based on the data and importantly based on the statistical significance. So what is that? That is what we are going to understand. And now Virat Kohli's batting average is 59.33. How do I know it is 59.33? Because I have data of Virat Kohli. All the matches he played is captured very well. Information is available. I can simply calculate average. So I have it. Since all the data is available, I can also calculate standard deviation. Possible. When standard deviation is available, average is available, I can also calculate the confidence interval. What is the confidence interval and the confidence limit for the confidence 95% confidence level? 55 and 65. That means you can expect him to score between 55 and 65 in any match. That's how we use the statistics. On the other hand, I have Rohit Sharma. Rohit Sharma's batting average is 57.87. He also has the data, 1 year data. His data has given me 57.87. And now Rohit's data also gave me, the standard deviation. So I found the, confidence limits, 95% confidence limit. These are found to be 57 and 63. These are found to be 57 and 63. Looking at the average, Kohli is found to be better than Rohit. But if I am an ordinary man, I will immediately say Kohli is the better batsman. But if I am a statistician, I will take a time to think about the statistical significance before differentiating the performance of Kohli and Rohit. Right? We need to be statistician always while taking decisions. And the third one, the third batsman, Ajay Jadeja comes in. Right? He comes into picture. His batting average is 31.88. Now all of you can answer very quickly. How you will say no, Kohli's performance is better than Jadeja. I think all of you will appreciate my statement now. What, sir? We all know Kohli is absolutely, a fantastic batsman compared to his, particularly when you are talking about the average, then he is more reliable. Kohli is more reliable. The data is making me to speak. Similarly, Rohit also found to be better than Ajay Jadeja because the confidence limits for Ajay Jadeja is between 25 and 40. You can expect him to score, you can use him only to score between 25 and 40. Don't expect a long innings from Jadeja. That's the message that is coming from data, right? And now, first conclusion. Virat's performance is better than Ajay Jadeja. How many of you support this conclusion? Virat's batting performance is definitely better than Ajay Jadeja. Come on, how many of you support? Okay, I think it's difficult to take the survey, right? Maybe you can put it in the chat box. Maybe few of you can try. I will try to use your data. How many people are? Yes. Pavitran says yes, and then Ajmal also says yes, and then Dr. Anita also says yes, Kulsam says yes. Many people are saying yes. That means all of you are now supporting my conclusion. Why you said yes? Because you are able to see the statistical significance. You are able to understand the difference is statistically significant. Your confidence levels are high in recognizing the difference that exists in the data. That is why you all agreed my finding. Second conclusion. Rohit's performance is also better than Jadeja. I think again all of you will support me. Isn't it? Maybe we can take the poll again. How many of you, support my statement? Is that good now? Let me check the chat box. How many yes and how many no are coming. Now again, Dr. Madan, Shalin Nair, Kulsham. Everybody is supporting me again. Again, it simply means people are able to, understand and recognize the difference is statistically significant. Yes, difference is statistically significant. Now another statement. Virat's performance is better than Rohit. How many of you will trust this finding and take action against Rohit? How many of you are willing now to take action against Rohit? Or give some rewards to Virat? Both are same, isn't it? And now, is this conclusion correct or wrong? How many yes, how many no are coming? Please go ahead. How many of you say yes to this conclusion? Virat's performance is better than Rohit. Yeah, come on, go ahead. Whatever comes into your mind, even you can be correct, you can be wrong also. Pavitran says yes, but it's a close call. Okay. He's doubtful. Doubt of uncertainty exists, right? And Madan says yes. Is there anybody who want to join me and say that it is a matter of doubt? How many of you feel like, it is not yes, not no, it is definitely a matter of doubt? Isn't it? It's a case like our Punithan, I believe. He said it's a close call, right? So the amount of uncertainty that is associated with respect to the third conclusion is high, because of which we are not able to recognize the difference as statistically significant. We will consider this situation as statistically insignificant. And we will consider this situation as statistically insignificant. Whenever you come across a situation where the difference is statistically insignificant, better do not take your decision. That's my suggestion to all of you. As a statistician, as a researcher, you must hold your decision. When situation is statistically significant, yes, take the decision boldly. You will be appreciated by everyone. You can easily defend your thesis. But when the amount of certainty goes beyond certain level, we call it industry standard, right? I will talk about that. When the uncertainty is more than the prescribed level, then we should not take the decision based on what we have observed in the data. The difference is not statistically insignificant, not sufficient enough to recognize the significance. How can I visualize, sir? How are you telling? Look at the confidence bands here. Confidence interval band of Virat Kohli is indicated here in green color, and confidence interval band for Rohit Sharma by light green color, and the confidence interval band for Ajay Jadeja I have indicated in red color. Since 25 is very low, it is on the extreme right. Since 65 is very high, it is on the extreme right. When you are comparing Kohli with Ajay Jadeja, do you see any interference between the two bands, red color and green color? Or is there a big gap exist? What is your conclusion here? 40 is here. There is a gap of 15 units, and then only the band for Kohli starts. No interference. Am I correct? There is no interference of the confidence interval bands between Kohli and Jadeja. That is why you concluded the difference is statistically significant. How many of you understand the statistical significance here? Right? The confidence limits of the two groups are not interfering. All right? Fine. And similarly for Rohit and Jadeja, again, they are not interfering. That's why I have written statistical significant. But when it is a comparison between Rohit and Virat, somebody said it's a close call. Why it is a close call? Because there is an interference. Am I correct? And interference is huge. Interference is huge. Discrimination is less. That is why, we concluded it is statistically insignificant. When there is no interference at a prescribed level of significance, you can conclude it is statistical significant. But when there is an interference, you must consider the difference as insignificant, and then you should not arrive on conclusion. Is that clear to all of you? What I spoke in this slide? Am I correct? Somebody respond to me. Is that clear? Or you can type in the chat. Understood? Statistical significance? Yeah. I could see people typing, clear. Very good. Clear means understood, right? Okay. So now we move on. So we should conclude only when the difference is statistically significant. We'll write conclusion. We'll take action based on the conclusion only when the difference observed in the research is statistically significant. In all other situations, it is better to keep quiet. If you are still doubtful, extend your study. Extend your study, and then if you feel like, you can raise your voice, then only you should raise your voice, right? So difference is considered statistically significant when error bars do not overlap, right? These bars should not overlap. Alternatively, This is one visual method, short, simple method. I wanted all of you to understand. That's why I used, the simple method. But today the famous method is, using a tool called p-value, which is a probability of significance. This tool p-value will estimate the amount of error or the amount of uncertainty in your decision, in your conclusion. All the softwares can give you the p-value. All the softwares can give you the p-value. This p-value is nothing but the amount of uncertainty. Amount of uncertainty in your data, and based on which you can judge whether the difference is significant or insignificant. I will talk about it slightly later. So the error is what actually affects the accuracy of our conclusion. Now there are two types of error. Whenever you collect data, there will be two types of error. Now also I can make all of you collect data. Generally in training program, I keep it more engaging, interactive, and then I make my people do some work also, like data collection and all, we do it. Now I'm not going to do it. So whenever you collect data, there is a possibility that error will happen. These errors can be categorized into any one of the two types: type 1 error, type 2 error. These errors will happen in manufacturing industry, maybe in a manufacturing scenario, service scenario, even in research. Everywhere these errors will happen. So you must understand what are these errors, and you must learn to control these errors. I'm not saying that please learn to eliminate this error, because elimination is not possible. This is the rule of the game, rule of the nature. Right? Always variation. There will be variation. That's the rule of the nature. We think every day is exactly 24 hours, but actually not. We think every year we'll have 365 days, but actually not. So this is the rule of the nature. What is this? This is rule of the nature. There will be variation. If there is a variation, there will be uncertainty. Right? You just cannot eliminate uncertainty. So there will be error, but you should be able to control them, minimize them to the desired level. That desired level is generally set by the researcher. You call it confidence level. You call it power of the test. Right? We'll talk about it. So type 1 and type 2 errors are generally caused by two things. One is poor measurement system. Poor measurement system. What is system? Several elements comprise a system. What are the elements? You are also an element of the measurement system, because you are also involved in data collection. The gauge you are using, that is also an element in the measurement system. The gauge is not good enough. You are measuring temperature, right? You are measuring the angle at which the ball is kicked. Yeah, but no, the measurement system has got a limitation. So these are all called measurement error. So the equipment, the appraiser, and the particular entity you are measuring, right? And even the environment can also cause error. All of them are part of the measurement system, right? So poor measurement system will lead to uncertainty in your decision, what is called a measurement. This measurement error should be restricted to 10% of the difference which you wanted to validate. The measurement error should be less than 10% of the difference which you wanted to validate. What do you call our Virat's average is 60, and our Ajay's average is 40, and so the difference is 20. What is 10% of the 20? 2. Plus or minus 2 is tolerable. Plus or minus 2 is tolerable. That plus or minus 2 can be due to measurement error. But however, today, particularly in sports, you have all modern equipments, and you use high-end technologies to capture the error. So you will be able to very much control them. So you don't have to worry much, but wherever the data is collected manually, this will also play its role, and then you will go wrong in your decision. All right. Now, poor sample collection. Poor measurement system is one thing. Poor sample collection. What is poor sample collection? I wanted to understand how, how the people are behaving, how the researchers are, doing the research in Chennai. But I collect data from Delhi, how the researchers are, doing the research in Delhi. But I wanted to understand, how the quality of research that is happening in Chennai, but in reality, I collected data from Delhi. Do you think the data I collected from Delhi will help me to understand, the quality of research that is happening in Chennai? No. If you want to understand Chennai, then you collect data, within Chennai. Have some strategy, have some technique. Fix on the amount of data, fix on, the technique of data collection. If the sampling frame is not fixed properly, that will lead to sampling error. If the sampling technique is not followed correctly, that will also lead to sampling error. If the amount of data is not sufficient, that will also lead to sampling error. So there are two ways you can go wrong. Even if you are data driven, data must be used in research and all those things, right? You have come a long way. Just to get into the research, you spent several years, 25, 30 years you did, but still there is one more challenge awaiting for you. What is that? Still the data can mislead you. That is what I'm trying to warn all of you. Still the data can mislead you. So it is very important for all of you to control the measurement error, to control the sampling error. For that, your knowledge on how to collect the data, how to validate the measurement system, what kind of sampling techniques are available, your knowledge on the characteristics of the population, normal distribution, exponential distribution, Poisson distribution, gamma distribution. These are all characteristics of the population. Though there are several distributions exist, I suggest at least all of you should become a master in normal distribution. At least normal distribution, you all should master fully so that you can handle 95% of the cases very effectively. So what is measurement? In order to handle the measurement error, you should have an idea about all these things: bias, linearity, and stability. You do a study to understand the bias in your reading. What is bias? The inaccuracy. The linearity, bias, linearity, stability. We need stable reading. Our reading should be linear. When you can ensure stability, ensure the linearity in your reading, you can effectively control the bias. How will you control the bias? You will calibrate the equipment. How to calibrate the equipment? You will get to know only when the readings are stable. How to calibrate the equipment? You get to know when your readings are linear. So very important, you make your device produce stable reading, linear readings. Then calibrate it at frequent interval, maintain it properly, then it will give error-free reading. The preferred scenario is bias should be 0. When you want to make the bias equal to 0, your reading should be, first of all, stable, your reading should be linear. So we will talk about all these things in detail, probably in the main program. Right. Gauge R&R study. How good your measurement system is. When I make use of this particular measurement system, is my data going to be worthy? Even before collecting the data, I will first validate. When I have to test my health of my body, I give a sample, blood sample. I will see to that I give my blood sample to some of the best laboratory in the country. So that the result that is going to come out is going to speak about my health and life, isn't it? My data should be error-free. So there are certain accreditation procedures which will judge the quality of report the laboratories are generating. You call it NABL accreditation and so on. Same way, you are using several measuring gauges. When you are doing the research, I do not know what kind of gauges you will be using, but definitely, with the deeper understanding, I will be able to help you. Are you using some stopwatch to measure the time taken to play a shot? Are you using some device to measure the angle of a shot? There are many things, isn't it? So those gauges needs to be validated. Very good. Then sometimes your data may not be quantitative, maybe more of subjective in nature. What I see it as okay, maybe not okay for you. What I see it as good, maybe you see it as bad. Suppose if all of you are asked to rate the training program or the webinar right now you are attending, some of you might give me 7, a score of 7. Some of you might give me a score of 9. There is a difference. We are not able to agree to each other, but the program is same. The delivery is same. All of you are listening the same lecture, but the perspective differs. And that means, with subjective data, again, the uncertainty is possible. Then you need to do a study called attribute agreement analysis study. So fundamentally, the type of data, your understanding on the type of data is also important. So the requirement is measurement error should be less than 10% of the difference to be validated. And coming to the sampling error, there are 2 types of error. Again, here also 2 types of error exist. In measurement also type 1, type 2 exist. In sampling also type 1, type 2 exist. Type 1 and type 2 error. Here we will call them as alpha and beta. Alpha is level of significance. Alpha is also considered as level of significance. Right. The type 1 error is also called as false positive. Type 1 error is also called as false positive and insignificant. You see, in order to understand the type 1 error and type 2 error, we need to measure them, and the symbol used is alpha and beta. The insignificance, when the insignificance is concluded as significant, significant. For example, the difference between Kohli and Rohit, the difference is insignificant. That's what our understanding. But if you still say, Kohli is better, then that will lead to type 1 error, right? The insignificance is concluded as significant. That is called type 1 error. Sometimes you might conclude significance as insignificant. Clearly, Rohit is better than Jadeja. But you still wanted to say, no, sir, both are same, sir. Let us take both of them in the team. The next match is World Cup. Let's give Jadeja also a chance. Then what is the kind of error you are committing? Type 2, right? And you are saying that, you are supporting that there is no difference between Virat and Ajay or your Rohit and Ajay. So ability of your study to correctly reject the insignificance. Insignificance means, yes, it should be insignificant only. When there is a significance, then we will call it significance. So when the difference is insignificant, if you are able to correctly reject it, correctly rejecting insignificance means what? You are concluding that difference is significant. So you have the ability to correctly reject insignificance is called confidence level. This will be a little confusing, but we need to discuss in detail. Then you will gain an absolute clarity, right? Similarly, the ability of your study to correctly conclude on the significance, the ability of your research to correctly conclude on the significance is called the power of test. So the confidence level and power of test are derived based on the alpha value and beta value. So that's why alpha and beta, the type 1 error and type 2 error should be minimized. When I minimize the type 1 error to, let us say, 5%, I am sure that my confidence level is at least 95%. Same way, when I minimize the type 2 error beta to be less than 5%, then I am sure that my power of test is at least 95%. What is power of test? The difference exists. It actually exists. Kohli is better than Jadeja. Actually, Kohli is better than Jadeja. Right? And that's called power of test, right? You correctly conclude the significance as significance. Hope I have not confused you, right? So now I will play a video and then I would like to ask a few questions to all of you. So please watch the video. Let me share the video probably along with the sound. Okay. So I'll play it now.
Has he been caught in front? An appeal, a big appeal from... Got convinced once. or conned once into going for it by... No, he's gone for it.
As well. Just on the top ribbing of the... This is the height factor. It's the height factor. It's got to hit the stumps.
You can see that one stump when he is shuffling in, was walked in.
Pitching a line and hitting. Yep. DRS specialist, Mahendra Singh Dhoni. And finally, CSK break.
Now, what is the error committed here? Who has committed the error here? Can somebody type in the chat box? Who has committed the error here? It is Dhoni or umpire? Yes, umpire. What type of error he has committed? He has committed type 1 error or type 2 error? Based on our discussion. What kind of error he has committed? Make a guess. I'll help you with. Wow, beautiful. Beautiful. I could see people typing type 2 error. Fantastic. You have got the point very correctly. Very good. Type 2 error. Right? The batsman is actually out. There is a significant difference in the direction of the ball. Right? There is a significant difference in the direction of the ball, which he is not able to recognize. So the umpire has committed type 2 error. Right? The significance exists, but it was not recognized. It was not considered as significance. And this is called type 2 error. And Dhoni was not happy with the decision and he opted for DRS. Then the decision is reversed and that's why the batsman is declared as out. If this kind of errors are not controlled or corrected, then your conclusions can be, dead opposite, right? We should be, that's why it's very important all of us understand the amount of error and then we must try to control them. So, once again. Yes. Just a minute. Yes, I will come to that. So, collected data is considered worthy for analysis if the measurement error is limited to 10%. And similarly, the sampling error must be limited to 5%. See, these are all set by us, but I'm only giving the industry standard. Sometimes, you can change it. So the measurement error should be less than 10%. 10% means 10% of the difference you want to validate. And then sampling error should be limited to 5%, particularly the type 1 error should be limited to 5%. And of course, type 1 also, type 2 also. If you limit both type 1 and type 2 to 5%, then you achieve your desired level of confidence. You also achieve your desired level of power for that research, right? So the power of research or the power of test and confidence level are important. And all of them depends on the alpha and beta, the type 1 error and the type 2 error. All right. And ultimately, there is a relationship within confidence level and your power of test, right? If you want to achieve higher power, then your confidence may drop. But look, there is an interrelationship. If you focus on one, then other will, you may have to compromise. That's the relationship. However, if you don't want to compromise, then the only option is then you must make your study extensive. The number of samples have to be increased, and then you will be able to manage. But your research will become little costlier since you have to do a lot of experimentation to prove the finding with the confidence as well as the power. So ultimately, the sample size, the difference in the statistics you wanted to validate, the confidence level and power of test, all the four are connected, right? If you fix 3 of them, then 4th one will get fixed because of your decision with respect to the other 3. That's the relationship. So, moving ahead. So, how to do the kind of analysis? Let's say inferential analysis. See here, nowadays we have DRS system and a lot of technologies available which can capture these kind of images. See here, the direction of the ball after pitching in the ground till it is moving towards the stump, everything is the real movement of the ball is captured and it is expressed in the white color. But exactly at this point, the ball has hit the batsman pad, and then further movement is only predicted. That means up to this is descriptive. If the description is good, then the remaining blue color is inferential. Right? The quality of your descriptive statistics decides the quality of your right. So the path of the ball is predicted based on the data you have in your hand, and it is estimated that the ball will definitely hit the stump, and then the batsman should be given given the LBW or something. All right. So now this study, right? See here, this blue color line is actually drawn by your artificial intelligence system and computer. How it has drawn? It was given that intelligence based on a simple statistical study called regression analysis. What is regression? The mathematical equation of the path followed by the ball. What is that? What is the the nature of the curve or the nature of the line that the ball has followed? The white color one. Is it a perfect straight line? If it is a perfect straight line, then it should be a linear equation. If it is not a perfect straight line, then it should be curvilinear. If it is curvilinear, what kind of curve it is? Is it going to be a parabola, or it is going to be a cubical one, or is it going to be a higher order? Look at your data, look at the visuals, and try to understand. In my opinion, it is definitely not a straight line. It is going like a parabola. So with all this knowledge, I can write the equation of the line, and then when I extend the image using the equation I derived, the computer can draw the line for me, the blue color line. That's how the people are taking decision. So this is how statistics helps in making meaningful conclusions in all fields, including sports. All right. So research method and the accuracy of the conclusions. You can go with the research method based on numerical data and visual graphs. I have seen today many people just make conclusion without giving importance to all the uncertainty what we spoke so far last 1 hour, right? That means their conclusions is purely based on the numerical data they have collected and the visual graphs they have. That means the conclusion is based on what they heard in the survey and what they have seen in the visual, some graphs. People simply believe what they see, but sometimes what you see may not be true, isn't it? And that is what we are testing by measuring the amount of uncertainty. So my recommendation to all of you is your research method should not only be based on data and graphs, but also based on the worthiness of the data, right? Your conclusion should be always based on the statistical significance. Look at the error bar, right? Look at the confidence limits, check for the overlapping. If there are no overlapping, boldly go ahead and make the conclusion, clearly specifying your confidence levels. Or otherwise, we are planning for a full course, a 12 hours course. Join us. We'll teach you each and every aspect of whatever the uncertainty we have been talking about so far. We'll make you really a pro, and then you can use some statistical softwares. Either you follow the error bar method, or you use the tools like p-value, or we call it based on the distribution. There are Z-score, there are T-score, there are chi-square score. There are so many scores are available, using which you can understand the significance. But nowadays, in the latest time, nobody uses the Z-score and chi-square score and all. Everybody uses p-value only. So it is very important for all of you to understand what is p-value, right? So findings are concluded not only based on the data and the graph, but mainly based on the significance, right? And the significance will tell us the level of confidence and the power of test we are maintaining in our study. All right. So now the remaining time I can discuss with you a case study. And this is the case I want to discuss, right? Applying all whatever we discussed, the statistics to a scenario in cricket, right? If you are a coach of a particular team, how will you take decisions, right? Or if you are a researcher doing research on behalf of a particular team or for a particular batsman, then how will you collect data and do it? That case study we'll be discussing. So I would like to stop here maybe for 1 or 2 minutes, only to encourage all of you, to ask few questions. Then again, this case study will take another 20 to 30 minutes. Are there any questions? Any questions? Anybody, you can put it in the chat box. Or shall we go ahead? We can go ahead. If there are no questions.
I request participants to feel free to raise your questions.
Or if you have no questions, and shall we go ahead with the case study? Please type, go ahead or case study, then I will proceed. My only requirement is you all should be able to follow me. There is no point simply, me delivering everything and you people are not following anything. That is not the agenda. Shall I go ahead? So I just, okay. So, okay. So your answer of asking me to going ahead, I will take the answer as granted for me. That means all of you are comfortably understood the lecture so far, right? The session so far. All right, that's really sounding good. So I've shared my screen again. So a simple case, let's see how things work here. The average number of runs scored by Rahul, the name of the batsman, per inning was 32.5 for the last 50 matches he played in the last year. The last one full year, he played about 50 matches, and then his batting average is how much? 32.5. However, his benchmark average was 40. His benchmark average was 40, but suddenly, last 50 matches, last 1 year, his central tendency was moving in a negative direction. The average moving in the positive direction is good for your team. Hope all of you understand my language. But the average moving down is not good for the team, not good for the batsman. That was happening. It's a bad sign for Rahul. And from 40, it came down to 32.5. As a result, the team started losing, more matches. This lowered the number of runs negatively, and the negatively affected his team's match result. The team won only 36% of the matches they played in the same time frame. All of you understand the problem statement? This is the research problem. Now you have to do the research and come out with an improvement plan. Is that clear? Problem? Yes. So problem statement I have explained. Now the data is available, the batting statistics for Rahul in the year 2019. There are 50 matches he played, and his benchmark average was 40. Whenever he was scoring 40 and above, he was known for it, and that is not considered a problem at all. If you are Rahul, you score 40 and above, then you are known for scoring 40 runs, and you are actually scoring above 40. Then you are very consistent. But when you do not score 40 and get out even before that, that will now be looked at as a problem. I'm going to call it a defect. What is a defect? Whenever you score less than 40 runs in an inning, then that is considered a defect. Since there are a lot of defects happening, your batting average came down. Otherwise, your batting average will comfortably, stay above 40. And now the median, anyway, it is given here. I'm reading it. Median is 15. I'm going to use only the mean. And standard deviation is 39.47. When the standard deviation is too high, what can you conclude? You can conclude, he is so inconsistent. When standard deviation is too high, it means, he is very inconsistent. His standard deviation is, it's look here, it is 36.4. That means uncertainty is more. That means he scored very less in several matches, maybe in single digits, right? And those are the things. And now DPMO, this is a term we generally use in the industry, may not be not required for you, but DPMO stands for defects per million opportunities, right? So he got dismissed 36 times below 40 out of the 50 matches. If the same fellow plays several matches, let's say 1 million matches he plays, then this many times he will score below 40 only. That is what is called a DPMO. This is mostly helpful in manufacturing scenario. And now how this number has a relationship with another number in statistics, which is called Z-score, or we also call it Z-score. All of us have studied in 11th standard. Z equal to X bar minus mu by sigma. Z equal to X bar minus mu by sigma. Nothing but the normal distribution formula of calculating the test statistics, Z statistics. That Z statistics is 0.92. Now the problem is improving this batsman's performance. This improving this batsman's performance is nothing but reducing the defects. When I reduce the defects, my Z score will improve. The real-time problem is improving the batting performance of Rahul. The statistical problem is improving the Z score. Any real-time problem in the world, any research problem in the world can be converted into a statistical problem. And solving the statistical problem is very simple. You require data. You must achieve statistical significance. Then, statistical solution can be offered. And statistical solution, already exists in a table, which is called standard normal distribution table. These are all created by, the stalwarts like Carl Friedrich Gauss. He created normal distribution. He created standard normal distribution table, and solution for all the problem exists in his table, right? So statistical solution is easier, but how to make your statistics approach the solution, we need to work in real time, right? And that is what we are going to understand from this particular slide. So the root cause analysis began. Why Rahul was dismissed, how Rahul was dismissed, and the team analyzed. He actually got out for 50 occasions, right? 50 matches he played. Out of that, 30 matches he scored below 20. 14 matches he scored above 40, and 6 matches his score was between 20 to 40. This is how his dismissals are. Now, where the most of the dismissals are happening, whenever he scores below 20 only. 30 matches he got dismissed because in all 30 matches he actually scored less than 20. That means he is prone to dismissal in while scoring the first 20 runs. Am I correct in the finding? He is prone to dismissals while scoring the first 20 runs. Once he scores the first 20 runs, then the further runs, he plays very well. His performance is found to be better once he stays in the crease and cross the 20-run mark. That is a finding I could make, right? So why was he dismissed so often before scoring 20 runs? That means playing the first 25 balls is the challenge for Rahul. And this study also shows that in the first 25 balls, he scores somewhere around 20 runs. So if he learn or changes his style of playing the first 25 ball, this problem can get solved. Now, stratifying the problem. What is stratifying the problem? Diving deeper into the problem, right? See here, out of the 30, how many dismissals? 30, right? 15, 22, 20, yes. See here, out of the 30 dismissals, in which, in the matches he scored less than 20. These are the type of dismissals. Caught behind, he was caught behind most of the time. Caught behind means, somebody behind the wicket catch the ball. Maybe the slip or the wicket keeper. So near about 15 times, half of the time he was caught behind. Half of the times he was caught behind. But look at the number of caught behinds when he actually crosses the 20-run mark. It was very less, just 7 times. 7 out of 20 when he scores more than 20 runs. But 15 out of 30 when he scores less than 20 runs. So what is your inference here? He is prone to get dismissed, particularly by caught behind, when during the first 20 runs. So he has to be very, very careful while playing the first 25 balls or while scoring the first 20 runs. All of you understand how this Pareto plot is helping us to understand the problem to a deeper extent. Now again, it is the same graph. And now, since caught behind was the most frequent cause for the dismissal, right? Particularly when he scored less than 20 runs. So why was Rahul getting caught by the keeper or by the slip fielder in the initial innings while playing the first 25 balls? So that is the question that creates curiosity for me, because the solution is going to lie in the answer of this question. So this is called why analysis. This is called what? Why analysis. You keep on asking the question why till you go to the root of the problem. So what were these 15 dismissals? What kind of shots he actually played whenever, in all the time, he was caught behind. So I am going to go for the type of shots he played, right? See here, he played two types of shots, particularly, in the, in the initial stages. Either he can be defensive or he can be attacking. Defensive as well as he can be attacking. See here, how many times he caught behind? 15 times. All the 15 shots were selected. Out of all the 15 shots, 10 of them were found to be attacking and 5 of them were found to be defensive, right? So, and again, the attacking shot, what kind of attacking shot they were? Some of them were hook shot, pull shot, some of them were uppercut, some of them were square cut. Now, as a coach or as a statistical expert, as a researcher, I understand that he got dismissed, most of the time because of, the attacking shot he played, particularly the hook shot, pull shot, and the uppercut shot. Hope all of you understand, the root of the problem, right? So these are the various kind of shot he played. So now, why was Rahul, getting caught in the slip and other things? Because he was playing attacking, because he was playing the hook shot, pull shot, and the uppercut shot. So now, some more statistics of his innings, particularly in the first 25 balls. The first 25 balls, the total number of shots he played were 28 shots, right? And out of that, 10 times he got dismissed. That means the defective percentage of the defective shot is 35.41. Now for this 35.71, 90% confidence interval. We spoke about confidence interval. That comes here. So confidence interval are marked here. And now the p-value. P-value I told you, right? P-value talks about the amount of estimated type 1 error in your study. So that is very good. That is close to 0. It cannot be 0, but software brings a value of 0 because it has limitation. Beyond 3 decimals, it cannot show. So it is showing as 0. Now he just balls per dismissal is found to be 2.8, just 28 divided by 10. So these are the statistics that tells me how frequently he is getting out because of this poor shots played by him. So the root cause analysis have to be done. So Rahul and all the team member, the team captain and coach and some experts and all of them were called for a brainstorming session. And then the brainstorming has thrown a lot of light on this particular problem. Why he got out, particularly while playing the first 25 balls, particularly before scoring 20 runs. And see here, the reasons could be generally this is called fishbone analysis or cause and effect analysis or Ishikawa analysis. Nothing but a fishbone diagram, right? Generally, people have these gettings: man, machine, material, method, measurement, environment. This looks like a manufacturing related kind of diagram, but you can use it in your research also, right? Man means the problem related to the batsman. Batsman himself, maybe he was psychologically upset. His fitness was not correct. All those kind of problem you can put here. And then machine, the type of bat he is using, right? And the type of pad and other things he is using, right? The equipment used, for example, the system that is used in the match, the cameras and other things, all of them come here in the machine. And then the material involved, the pitch is a material, the ball is a material, the kind of, those are materials. And then methods. What are methods here? The batting style, the bowling style, the batting position. These are all the methods that decides the outcome of the particular game. So these are the methods. And of course, measurement, nothing has been written. Why? Because nowadays the games and sports have become very modern, and all sophisticated facilities they use. And that's why the less of human intervention is used for data collection. That's why nothing has been written here. And if you are also using such a kind of sophisticated equipments, you really don't have to worry about the measurement error. However, the other errors are possible. And now environment. What is environment? It is not only the environment condition, any factor that is beyond your control. Any factor that is beyond your control. The next 1 year match, maybe in any pitch, that is out of your control, isn't it? So the venue, the timing, it can be, a game, day match or day night match. And these also can become a reason for the dismissals. But these are all definitely beyond your control. So you need to know, to play with the limitations. Certain factors you can't control. So you have to live with them. So such factors will appear here, right? And now some of the factors are indicated by red color. Why indicated by red color? The people who participated in the brainstorming, the experts, the batsman, the coach, and all of them were doubtful. Their suspect were more on these factors. So it becomes very important for you to study deeper into all these suspects. These factors could be definitely one of the factor or few of the factor or all of the factors could have been the culprit for Rahul's performance. If you set all these factors favorable for Rahul, then Rahul's batting average will again improve. Out of all the red color point, only one is coming under the environment. That means it is beyond your control. Batting innings, right? Whether Rahul is playing in the first innings or he is chasing, that is not in his control. You can't do anything, right? You have to live with it. If you win the toss, if the captain chose to bat, then you will bat first. If it is a chasing game, then you need to chase. You have to play under pressure. So this also is a reason, but you don't have control over it. So you can try to improve the result or solve the problem by working on these factors. All right. And now, in order to validate these factors, now you can convince everybody about about these red color factor. If everybody agrees, yes, this is the reason, let us work out an improvement plan, then it's okay. Suppose people are not believing on some of the red color lines indicated, you have to create evidence. You have to give statistical evidence. Giving statistical evidence is called hypothesis testing. It's nothing but a simple procedure by which you will prove that these factors are critical. You will prove that the difference in the performance due to these factors are significant. That is called what? Hypothesis testing. There are several types of testing exist, which you will be learning in the detailed program. Probably 10 to 12 hours we need to stay together so that you can master all of them. Some of them are Z tests, some of them are T tests, some of them are ANOVA, some of them are chi-square, right? You will learn that little later. So all the red ones are indicated. Now, the project team did not find any difference in Rahul's performance when he was batting first or when he was chasing. So though that was a suspect, but still his score, whatever average he maintained when the team is batting first or batting the chasing level, almost the average is same. So though the factor is not under the control, the suspect, you don't have to worry. And his performance on the flat pitches, however, was better compared to the green pitches. So what was affecting Rahul's batting while playing on green pitches? When he was playing on green pitches, the performance was going down. So what is that? So Rahul was found to perform better on the green pitches when he was not required to open the inning. How do I know? Again, the data. When he was opening the innings as an opener, look at his average. His average is 12.125. When he was actually played for the fourth position, his average was 52.55. You're getting a clue. You're getting a clue. So he should be advised to play at number 4 and not at number 1. That's one thing. And on green pitches, his batting average is 4th position. And compared to 12.1, when actually this there are two factors we are dealing now. One is the position. Another thing is the type of pitch. So whether it is your green pitch or the flat pitch, and particularly it is found that in the green pitch, when he was asked to play at number 1, he was struggling. So for green pitches, it was recommended that he should play for the in the 4th order. And since changing his order frequently will disturb the rhythm of the game, for both the flat pitches as well as green pitches, Rahul was recommended to play in the 4th position, right? And because he was consistent enough at the 1st position as well as 4th position as well as the flat pitch is concerned. Only in the green pitch, when he was opening, he was struggling. So such a decision was made. Now, and also effect of the bowling style on Rahul's performance, right? And see here, he has played totally 793 balls, the right arm seam, the left arm seam 298, and then leg spin 257, off spin 436, and left arm spin 199. And out of which, defective shots. What is defective shot? He get the dismissals, and these are the thing, right? So they were marked, and percentage defective were calculated, and the confidence interval were calculated. And that means, see here, particularly the left arm seamers, it was very high, and so it is understood that he was having issues while playing with the left arm seamer. So you must have some improvement plan as per the left of the left arm seamers were concerned. So we slowly go deeper into each and every aspect of the factor, and then to come out to work out on the improvement plan. So here the confidence intervals were drawn. You can understand the left arm seamer, his confidence interval band is not actually interfering with these two. A small marginal interference with this and with this. That means the problem is mostly found to be with the left arm seamer. The percentage is defective. Most of the balls which are played wrongly by Rahul was found to be with the left arm seamers, and that's why his chance of playing defective shots were more, and so improvement is required in that aspect. So now the improvement plan. Batting style. Hook, pulls, and uppercut were contributing to the maximum number of dismissals at the start of the innings. And so what is the improvement? Needs to avoid playing these high-risk shots in the initial stages. First 25. Actually, this count what we have taken here earlier was these shots were considered defective. He was not supposed to play these shots, particularly while playing the first 25 balls, but actually he played, and particularly he played more with respect to the left arm seamers. And so this is the suggestion, and the responsibility was given to the batsman and the batting coach and the team captain. And then the second one, pitch. Rahul's batting average on green pitch is significantly lower compared to his performance. The problem is facing the new ball at the start of the innings on green pitch that suits seam bowling. So he does well bat lower down in the order on green pitches. So Rahul should be placed in the 4th position because he was having problem with the green pitch, particularly when he was asked to open the innings, he was having problems. So he was advised to play at number 4. And since Rahul's batting is consistent at all positions, this decision was implemented for flat pitch as well as the green pitch. And again, the responsibilities were assigned. And then as per another factor, the bowling style. Rahul tends to play more false shots or the risky shots. Nothing but these kind of shots. He played more with respect to a particular bowling style. What was that? Left arm seam bowler. And you can understand that with this graph. Near about 21% of the balls he faced from the left arm seam bowler, he actually played the risky shots. That too, particularly in the first 25 balls before scoring 20 runs. So Rahul need to play left arm seam bowlers with an open stance. What is open stance? Something like this. He has to adjust his the standing posture, and so that he can actually play the ball better. So there would be a mandatory left arm seamer bowlers during the net sessions. So the responsibilities were assigned. When these suggestions, improvement actions, when these improvement actions will be implemented, do you think the root cause of the problem will get fixed? Obviously, right? And that is what happened with respect to Rahul's case also. He was advised to follow all the improvement suggestions given by the coach and the team, right? The research team. And as a result, you can see in the next 28 matches he played, this is the average he achieved, right? 49.52. The average of 32.52 has improved to 49.32. This is called, the root cause analysis. The root of the problem is identified, understood, and also validated statistically, and then actions are taken. And these are the other statistics, no need to explain. And innings played and defective innings and DPMO, you see drastic decrease in the DPMO, and you can see the improvement in the form of your Z score, right? And so the percentage defective, which was 72 earlier, dropped to 43%. And if you keep on working in this fashion, probably you can help him further also. So that's it from my side as far as the this short program is concerned. And those of you who are seriously interested in learning more with respect to the statistical approach required in statistics, we are coming up with a full-fledged program where I will be taking you through a complete 12 hours module, more interactive, and then where you will also be equipped and to work with two statistical analysis software. One is Excel, the other one is Minitab. And so all these formulas and other things will be taken care by the the tools of the softwares. But you should be very good at knowing which tool will be more appropriate for making your findings worthy for the applications. So any questions anybody would like to ask? I'm open to your questions. Okay, if there are no questions, I think Vignesh, shall I ask Prabhakar to tell about the
Yes, sir, please, sir.
Yes, Prabhakar, you can share your slide. Show the just one slide information about the program.
Sure, sir.
Those who are interested, they can ask for the details. Yeah.
Vignesh, can you please able me to share the screen? Screen sharing option is not disabled for me.
Just a second. So now I made you post.
Yes.
Vignesh, can you enable me?
Just a second.
Okay.
Okay, otherwise you can send. email also, if there is an issue.
Sir, I made my host.
Yes. Are there any questions or any participant you would like to say something? Let us break the silence. We have another 10 more minutes.
Sir, Professor Nallavan sir has raised his hands.
Yes.
Sir, it was a real good session, sir. Actually, this was the need of the hour because we all know statistics there, but the problem is how to make that into happening. That is, in sports, we were not that much aware of. So it was really a wonderful session, sir. So this has given a hands-on training for our students as well as to the faculty also to understand what is exactly happening in the real field. It was a wonderful session, sir. Thank you.
Yeah. Thank you. Okay. So, is there anything else? Any other agenda?
Yes, sir. Any doubts? Any doubts from participants? So, Prabhakar sir, you can share about next course. Hello.
So
Any participants willing to give a video feedback? You can.
Yes.
so I will share you this
Any
link.
participants are willing to give any feedback? It will be great help and I'll be supportive for us.
Feedbacks are most welcome. Questions are most welcome. And feel free.
Nice presentation, sir. It's really wonderful. We are very grateful to you for spending your valuable time with us. We are expecting such more interaction in the days to come. Thank you. Thanks a lot.
Thank you so much. Thank you. Janita, madam, you wanted to add anything? The raising hand.
Hello.
Yes, madam.
Okay. I'm working at
I think you have the networking issue. Network issue, I think. Madam.
Your voice is not audible.
Yeah, network issue.
Anita, ma'am? Yeah.
Yes, maybe those want you can share in the chat box also. We get to know how helpful the session was.
Sure, sir.
Right. It was.
Nallavan? Dr. Nallavan, please propose a vote of thanks.
Yeah. So meanwhile, a link was posted by Prabhakar. Yeah. Yes.
Yeah. Participants, we are having upcoming program on statistics for research in sports. So this is planned in the month of March. So I have shared you the link also for this program. So those who are really interested, they can register for this program. And for further clarification, you can reach us. We'll be sending the email also regarding this program shortly.
So back to organizers.
Thank you, sir. Thank you so much for valuable time, sir. I thank all participants. Thank you for attending the webinar. Thank you so much.
Then shall I leave the meeting?
Yes, sir.
Yes, sir. Thank you, sir.
Thank you. Thank you, sir.
Thank you all very
Thanks
much.
for all.
Hoping to see you all in the next program. Bye-bye.
Sure, sir.
Thank you, sir. Thank you.
Thanks to one and all. Okay, Vignesh.
Okay, sir. Thank you, sir.
Okay, thank you. You may quit.